Welcome to Homework Lib.
Chapter 14, question 58. Indicate whether each statement is true or false. So at first, they suggest if you measure the rate constant for a reaction at different temperatures, you can calculate the overall enthalpy change for the reaction. So let's try it. Um, the Arrhenius equation for K1 and K2 and add them up together. What we're going to have is ln K1 over K2. This is actually when we subtract them from each other. What we're going to get is energy of activation over R, 1 over T2 minus 1 over T1. So if you know this case at different temperatures, which means we also know the temperatures, and R is a constant, we can find the energy of activation. But does it tell us the overall enthalpy change? So if you draw a plot of energy versus the reaction coordinate, let's say we got a endothermic reaction, and this is going to give us the energy of activation. But the overall enthalpy change is going to be the difference between energy of products minus the energy of reactants. So we need to know these two values, not the energy of activation, in order to get the enthalpy change. Exothermic reactions are faster than endothermic reaction. Uh, Not really. What we suppose is exothermic reactions are most likely going for a spontaneous reaction, which we're going to learn in the next chapters. It doesn't mean all the exothermic reactions are spontaneous, but mostly the exothermic reactions are spontaneous. So if you increase the temperature, the reaction's going to go faster. The K values are depending on the T values. So whichever has more temperature is going to go faster. If you double the temperature for a reaction, you cut the activation energy in half. The activation energy does not change with the temperature. What changes with the temperature is the value of K, but we cannot change anything about the activation energy even if we change the temperature.